Hello again, GCSE PE students. So today I'm going to attempt to explain the respiratory system. You'll have been sent resources to work through on Google Classroom. So this resource is just simply trying to explain the system to hopefully help it make sense and be remembered. Now, the respiratory system, we're going to firstly look at how we breathe. So how do we breathe? Well, what we need to do is increase our thoracic cavity. So to do that, our intercostal muscles contract, as does our diaphragm, which expands our rib cage. And by doing this, the thoracic cavity or the lung space will increase. Because of this, there will be a lower pressure inside the lungs and the atmosphere, meaning that, as we all know from science, that air always wants to travel from an area of high concentration to an area of low concentration. So the air will literally leave the atmosphere and come into the lungs. When we breathe out, the reverse happens. So our intercostal muscles relax, as is our diaphragm. And because this happens, we have a smaller thoracic cavity with a higher pressure. This higher pressure is greater than the atmosphere, and so the air wants to escape. So when we breathe in, intercostal muscles and diaphragm contract, meaning we have a greater thoracic cavity space with a lower pressure, meaning that air will come into the lungs. And when we breathe out, the reverse happens. The intercostal muscles relax, the diaphragm relaxes, giving us a higher pressure inside the thoracic cavity, inside the lungs, so the air will then want to escape. And that process happens, we breathe in and we breathe out. As this is happening, we are also getting diffusion in the alveoli. So as we breathe in, the air is richer in oxygen. However, in our alveoli, our alveoli at that moment contains lots of CO2, lots of carbon dioxide. So through diffusion, if there's lots of oxygen in the lungs, but not much in the alveoli, the oxygen will want to go into the alveoli, and vice versa. In the alveoli, there'll be lots of CO2, lots of carbon dioxide, and because there's not very much CO2 in the lungs, then that will want to take place, that diffusion will want to take place, that gaseous exchange. So we'll get literally a swap of oxygen for CO2. Now, as we exercise, we will produce more CO2. So the more CO2 that our alveoli are passing through to our lungs, the more oxygen that we can take in. So our oxygen demands can increase when we exercise, but that can only happen if we are producing more CO2. And that's why a warm-up is so important in sport, because the more CO2 we are giving out, the more oxygen we can get in, and so into our body to be used. Okay, that's the first part done. The second part, which I'll try and explain again, is looking at something called respiratory values, which I've got written down here. Now, when we breathe in 78% of what we breathe in and out is nitrogen. We don't use nitrogen, so we breathe in what we breathe out. And the difference is we'll breathe in 21% oxygen, but we breathe out 16% oxygen. So this means that our body is generally taking around 5% of the oxygen that we take in from the atmosphere, we will use or will be taken in by the alveoli into the body. And CO2, we will generally breathe in around 0.04% of the air we breathe in is CO2, but we breathe out is around 4%. So that's showing us that as we are exercising, we are taking in more oxygen and then breathing out more CO2. And the reason for that is because obviously as our muscles are exercising and working out, using the oxygen, converting the oxygen to CO2, we then, through the cardiovascular system, get this out to our lungs where the gaseous exchange can take place. And the last big thing we need to look at is lung volumes. So I've drawn a little diagram here, which hopefully you can see. I will try and explain it. So first thing we have is tidal volume. Now, tidal volume is the amount of oxygen that we are breathing in. So not oxygen, air we are breathing in per breath. As we exercise, our tidal volume increases. Now, there are two more words we need to look at here. We have total lung capacity and vital capacity. Total lung capacity, I've put is down here. Now, total lung capacity is the amount of air that you can have in your lungs. So if you have a maximum breath in, breathing as much as you can, your total lung capacity is how much air you'll have in it at any one time. However, vital capacity is slightly different to that, because we must always have some air in our lungs. If our lungs have got no air in, we have what's called a collapsed lung, which is a very, very bad thing and dangerous. That only really happens if someone has a punctured lung through a car accident or a heavy impact. So our vital capacity is the amount of lung capacity, the amount of lung space we can actually use. Our total lung capacity is the amount of air that can be in our lungs at one time, but the vital capacity is the amount of that we can actually use. And our total capacity, our tidal volume, is how much we are actually using at that time. So if we are using our tidal volume is here, for example, okay, and here is our vital capacity. If I start to exercise, my tidal volume will increase, but it will only ever increase up to vital capacity. The bit at the bottom here, we can never ever use, because that is what is left in the lungs at all times. I hope that makes a bit of sense to you. And the work that I'll set on Google Classroom and using the BBC Bite-Size website will help you further with this information.